we continue review in pre-calculus. First we prove these identities. Usually to get the idea of the relation between the functions in an identity, we're just trying to simplify it. And this is not a proof. The proof should not be established from something that we're not sure is true or not. Right. So first I will rewrite everything in let's just cross multiply just to simplify. Once again, it's not a proof. So write this over 1 and then cross multiply. We have 1 plus cosecant x. That when we cross multiply, and then we have secant x times cosine of x plus cotangent x. Right. Now I just multiply it out, and then we write everything in terms of sine, cosine. Cosecant is 1 over sine, and secant is 1 over cosine. And then we just have cosine of x. Cotangent is cosine over sine. Now we don't do anything on, because we know that when we multiply them out, cosine cancel out. That's just 1, and cosine cancel. We just have 1 over sine x. And so they are the same because they are equal. So the actual proof, if we want to, we can just write everything in the reverse order, and we should have the proof. However, when we write like this, we kind of see the relation of the function. So this one actually fairly easy. If we start with the left hand side, 1 plus cosecant of x, and then secant of x. That's the left hand side. What we do is just we write secant as 1 over sine, 1 over cosine. And then divide fraction is multiply reciprocal, so we're going to flip it. We have 1 plus cosecant of x divided by 1 over cosine is multiplied by cosine of x. And when we multiply it out, we have cosine of x plus cosecant x cosine of x. And cosecant is 1 over cosine, 1 over sine. And so we have cosine of x. Cosine divided by sine is cotangent, and that equal to the right hand side. And so we have the proof. So this should be a proof. Of course you can write this in reverse, but not as standard as this proof here. Right. So that is the first one. So let me write a timestamp. The next one, it will be easier for the next one if we just try to simplify first, because you go from this side to that side might not be obvious. So first I'll cross multiply. Again, I don't emphasize enough, this is not a proof. And then we cross multiply. Right. Cotangent is cosine over sine, and cotangent square is cosine square over sine square. times sine x. And cosecant we can write as 1 over sine. And we just cancel the sine, and so we have cosine square over sine x equal to, now we multiply it out, 1 over sine x. 1 over sine x times sine x cancel out. We have plus 1, and then minus 1, and then minus sine x. Of course, the minus 1 cancel out. We have cosine square over sine x equal to 1 over sine x minus sine x. Now here we just multiply both sides by sine x, and sine x, so we cancel, we have cosine square equal to 1 minus sine square. And we know this is true because that is the Pythagorean theorem. We can move to one side and we have cosine square plus sine square equal to 1. Again, this is not a proof, but if we write this in reverse, it will be a proof. I'm not going to do that, but if we write that in reverse, that will be a proof. Right. Next, find the exact values of the expression. So pretty much we just use the sign of a sum or difference. 165, there's a lot of ways to have 165, 120 and 45. Yeah, let's try that. So we have sine of 45 degrees and 120, and now this is sine of a sum. Sine of a sum is, the function is going to be difference, but the sign in the middle are the same. It's the same. Right. So we have sine. I'll just put the 45 degrees, 120, 45, 120. Sine of 45 degrees. That's square root of 2 over 2. Cosine of 120. So that is negative 1 square root of 3. Negative 1 over 2, sorry. Negative 1/2. Right. Yeah. And then plus cosine square of 2 over 2. And sine of 120 square of 3 over 2. And then multiply across. Common denominator is 4. And so we have negative square root of 2 and square root of 6. Right, we're going to write like that. Next, tangent of pi over 12. If we don't want to work with the radian, we can always change to degrees. So pi over 12. If we don't want degree, if we want degree, we're going to put degree on top and radian, pi radian, and pi at the bottom. So pi cancel out, 180 divided by 12, that's 15 degrees. That's easy, 15 degrees. There are a lot of combination. 45 minus 30, 60 minus 45, or 135 minus 120. A lot of different combination. But we use 45 degrees minus 30 degrees. right? So tangent going to be tangent of 45 degrees minus tangent of 30 degrees over 1 plus tangent of 45. So that's the sine of a sum. 45 degree and tangent of 30 degree. Right, tangent of 45 degree is 1 and tangent of 30 degree 1 over square root of 3, and then 1 plus 1 times 1 over square root of 3. If we multiply square root of 3 top and bottom, we should have square root of 3 minus 1 over square root of 3 plus 1. We stop at that point. If we want to, we multiply by the conjugate at the bottom. So we have to rationalize the denominator. The conjugate meaning if there's a plus, multiply by the minus in the middle. Right, multiply them out. Square of 3, that is 3 minus square root 3 minus square root of 3 and then plus 1 over square root of 3 square, so it's 3 minus square root of 3 plus square root of 3 minus 1. Bottom line is we have 4 minus 2 square root of 3 over 2, and divide 2 top and bottom, we have 2 minus square root of 3. We could just stop at this step if we want to. Right. And now we're applying the sign difference. So we start with the sign alpha minus beta. It's going to be a long one. So sign alpha minus beta, the sign of a difference. For sign the function at different, but the sign in the middle is the same, so that minus, so this also minus. And then we have alpha, beta, alpha, beta. Sine of alpha, that is 15 over 17. Cosine, we don't know. Actually, we do know. Is 5 over 13. And then cosine of alpha, we don't know. And sine of beta, we don't know. Right, just need to find a question mark. Right, so try to first focus on this alpha. Sine of alpha is 15 over 17. Sine, we can write y over r, or opposite over hypotenuse. I use y over r. And this is in the quadrant 2. Right. So when we write like this, obviously r is 17 and y is 15. So if we draw a triangle, y is 15, r is 17, and then x will be plus or minus square root of 17 square minus 15 square. So that be how until 17 square minus 15 square. I have a calculator here. 17 square minus 15 square, that is 64. So that pretty much plus or minus 8. Now since this is a quadrant 2, so actually it's quadrant 2, we're going to choose x to be negative. Because of that, what we have is cosine of alpha is x over r is negative 8 over 15. Right. Next we use this. Beta is in first quadrant. So cosine of beta is 5 over 13 and cosine is x over r. So obviously from here r is 17, r is 13, x is 5, and we draw a triangle. X is 5, r is 13, and y is plus or minus square root of 13 square minus 5 square. That gives us plus or minus 12. Right. Now beta from 0 to pi over 2, meaning in the first quadrant. If it's in the first quadrant, we're going to choose the positive. And finally, sine of beta is y over r, so 12 over 13. Right, so put everything back into the original problem. 15 over 17, 5 over 13 minus alpha, cosine alpha, negative 8 over 15, and then sine is 12 over 13. Right. So let's just use a calculator here. (15) divided by 17, 5 divided by 13, minus negative 8 over 15 times 12 over 13. Right, we can convert this to fraction, and that have 19 over, wait a minute, this should be 17, sorry, yeah, because r is 17, right, and try that again. Right, negative 8 over 17. Right, try that again and convert to fraction. Right, 171 to 221. Right, next we'll combine the sine and cosine together. I only need to do one of them. The other one will be very similar. Right. So whether we have an A or B in front of it, the first thing we do, first I'll put the calculator away. First thing we do is divide by square root of A squared plus B squared and then multiply. So we have 2 and 3, those are A and B. So we just start with that. So pretty much we multiply it to a problem, pretty much. But we cannot just do that. If we multiply, we have to divide. So just pretty much multiply and divide by square of a square plus b square. Actually, we have 2 and 3 in this case. So 2 and 3. 2 square plus 3 square. And then sine of theta. Right. So, sorry, let me write that again. Square of 2 square plus 3 square. So that is 4 and 9 square root of 13. And then we have 2 over square root of 13 cosine theta plus 3 square root of 13 sine theta. Right. Now the reason that we multiply and divide by square root of a square plus b square, because after that we're going to let this equal to a sine and this equal to a cosine. The reason of that is we have the sine of the sum. So if we write this as a sine of let's say the angle of phi, and this one will be cosine, and then we have sine cosine and cosine and sine, so that will be just sine of a sum of theta plus phi, where phi is the angle, I should say sine of phi is equal to 2 over square root of 13. So that's all we do. So we combine the two trig functions using sum or difference of a sine or cosine. So here with cosine, so we divide by square root of a square plus b square, and then one of them is sine, one of them is cosine. Preferably, we want the sine with cosine, and then the cosine with sine. That is a sum or a difference of a sine. Right, so let you do the other one. Right. Next is double angle. Find sine of 2 theta. Sine of 2 theta is 2 sine theta cosine theta. We know cosine already, we just need to find sine, and that should be very simple. Sorry, you haven't seen the from. So we do 90. Sine of 2 theta is 2 sine cosine. Right. So we have cosine already, just need to find sine. Alright, so cosine theta 7 over 25. Cosine is x over r. So we have a triangle. Angle is theta. X is the adjacent is 7. And r hypotenuse is 25. So y is equal to plus or minus square root of 25 square minus 7 square. 25 square minus 7 square. That's 576, and square root of that is 24. So that's just plus or minus square root of 24. Plus or minus 24. Now, theta from 1.5 pi to 2 pi, meaning this is in quadrant 4. In quadrant 4, y is negative. So we're going to choose y equal to negative 24. And finally, sine is y over r is negative 24, r is 25. So we have 2 times sine, which is negative 24 over 25. Cosine is 7 over 25. 25 squared at the bottom, 625. And on the top, 2 times 24 times 7, 2 times 24, that's 48 times 7, 336, but with the negative sign. Right, so that's what we have on that one. Right, there's another double angle. So sine is equal to negative 4 over 5, and theta in quadrant 4. Right. Once again, sine of 2 theta is 2 sine cosine. And we have sine is equal to negative 4 over 5. And sine is y over r. So obviously here r is equal to 5 and y equal to negative 4. So we can put in the right triangle. X we don't know. Y is negative square root of 5. Negative 4, sorry. R is 5. And x equal to plus or minus 5 square minus negative 4 square. So that is 9. Square of 9 is 3. So plus or minus 3. This is in quadrant 4. In quadrant 4, x is positive. So x is going to be positive. So we have x, y, and r. And finally, cosine is x over r. X over r. So we have 2. Sine is given negative 4/5. Cosine we just found, which is 3 over 5. Multiply straight across, that gives us negative 24 over 25. Right, next, use this information to find the exact values of cosine of theta over 2. So this is half angle. Cosine of half is going to be equal to plus or minus square root of 1 plus cosine of 2 theta over 2. Right. That is not 2 theta, sorry. That's pretty much twice of this, so there's no 2 here, just theta. Right, which is negative 3 over 5, so that's easy. So plus or minus 1 minus 3 over 5, negative though, over 2. Right, so that plus or minus 1 plus 3/5 divided by 2. Multiply top and bottom by 2. So we will have by 5. So we will have 5 and 5 try to cancel. 5 plus 3 over 10. Right. We still have the square root and then plus or minus. We just still need to determine that. So divide by 2 everywhere. We should have pi over 2, theta over 2, and 3 pi over 4. Right, so from pi over 2 to 3 pi over 4, this is in this quadrant. So that is part of quadrant 2. And quadrant 2, cosine is negative. So we end up with negative and we have square root of 8 over 10. Seems like there's something off. So I will put cosine in that 1 minus right. Actually, that cancel 8 and 10. That will be square root of 4 over square root of 5. If we break it up, multiply square of 5 top and bottom, and then we should be able to simplify. So I think just stuff that's there. Next, cosine of a sum. I'm sorry, from product to sum, and sum to product. Cosine times cosine, it's just 1/2 the cosine plus cosine. It could be either plus or minus. I do minus first. So it's 1/2 cosine of theta plus cosine of 6 theta and 5 theta, cosine of 11 theta. And then next, cosine minus cosine is 2 sine of a minus beta. Actually, it's negative. It can be either plus or minus. It doesn't matter because both of them are sine. Let's do the plus first. Actually, minus first. And then plus. Either way, we have negative 2 sine of 6 theta divided by 2 is 3 theta. And then sine of 7 theta. Right. I could just have some simple application. A tree casts a shadow of 26 meters when an angle elevation of the sun is 24 degrees. And find the height of a tree to the nearest meter. So we have the ground level, a tree, okay, pine tree. Right, the sun. I'm supposed to be way out here, but we cannot draw too far, but that is the sun, the shadow cast like that. The shadow is 26 meters. And find the height of the tree. Let the height of the tree be x. And the angle elevation is here. When we look it up, if we look at that direction, that will be 24 degrees. Now this is rather obvious. With respect to 24 degrees, the x is the opposite and 26 is the adjacent. I'll just look for the ratio that have both of those, opposite and adjacent. So that actually would be tangent 24 degree is equal to opposite over adjacent. Just cross multiply x equal to 26 tangent of 24 degrees. Right. Just make sure that it is in the radian mode. I'm sorry, in degree mode. Right. So keep the calculator in degree mode. Wrong one. Need to move the calculator instead. So 26 times tangent of 24 degrees. Sorry. 26 times tangent of 24 degrees, and that is 11.57 something. I will round that to 12 feet of meters, so 12 meter. Right. Next, from the edge of the cliff, that is 100 foot height, angle depression to two cars is 21 and 28 degrees. How far are the cars? So again, I'm going to draw this. I will have the edge of the cliff, and the height of the cliff is 1,000 feet. And when we look down, there will be two cars. Let's say one here and there. When he looked down, the first one is 21 degrees, or one of them is 21 and the one is 28. Right, the small one is 21 degrees and then the big one is 28. Right, how far is the cars apart? Right, we know that the height of the cliff is very relevant. That is 1,000. So pretty much we have two right triangle. One is AC and D. So triangle AC and D. I just need to find CA. CA is, now if the big angle is 28, then we have adjacent and hypotenuse, so that will be a tangent of angle D, which is 90 minus 28, 52. Equal to opposite, which is AC, over hypotenuse, or over adjacent 1,000. Write that over 1 and cross multiply AC equal to 1,000, tangent of 52 degrees. Calculator again. It should be still in degree mode. 1,000 tangent of 52. I should have 12,079 and 94. Now we look at the triangle BCD. Now what we have is tangent of this complement 3 is 21, so 90 minus 21 is 59. Tangent 59 degree is equal to, opposite to that is going to be CB or BC. over the adjacent of 1000. So BC equal to 1000 tangent of 59 degrees. Sorry, I have the calculator on the way. Right. So triangle BCD with respect to the supplement angle of 51 degree. So we have this. If that is 21, this here is going to be 59 degrees. Take away 21, we have 59 left, and then we do the math. 1000 tangent of 1000 tangent of 54 degree, and we have that. And we'll just subtract this number, the distance BC, subtract the distance AC, and that's what we have. So AB is CB minus CA, and we have 96.44 meter. Next we're going to solve triangle, oblique triangle. So we use the calculator a lot. So put the calculator permanently that corner for these problems. First, triangle ABC. So it doesn't matter how we get the information. It's always a summary. I'm going to put in this little table just the summary of the problem. What we have, what we're going to find. Angle A is 26 degrees. The sine A opposite to big A, we don't know. Angle B is 51 degrees. Opposite to B, again, we don't know that. C, we don't know angle C. But opposite to C is the little c of 22. Right, so 2 information to find the other 3. So that's a fair game. Right, first, the most obvious one is if we know 2 angles, we know the last one. So we subtract 180, subtract 51 and 26 from 180, minus 26, minus 51, and we have 103 degrees. Right, the rest is easy. Now if we have a pair of opposite sine angle, that is where we use the law of sine. I just write everything we have on the ratio. Sine of 26 degree, little a, don't know. Sine of 51 degree, little b, don't know. Sine of 103 degree, little c, 22. Right, and we just pick 2 ratio and then cross multiply and find what's missing. First, I'm going to pick A, the first one and the last one. Cross multiply, we solve for A, so we can write A equal to 22 sine 26 divided by sine of 103. We actually can enter fraction too, so alpha y equal to give us a fraction of 22 sine of 26 degree divided by sine of 103 degrees, and we have that. I round the answer to the nearest 10, so that's 9.9. I don't have the unit, so just put 9.9. Put that in red so we know that we found it. And finally, to find b, we're going to take this ratio, cross multiply, and we have b equal to 22 sine of 51 degrees over sine of 103 degrees. Again, another fraction. Right, so in degree mode is good. Make sure in the degree mode. Now we have fraction 22 sine of 51 divided by sine of 103. And b, we have a 17.5. And the unit is whatever the unit we use to measure the length here. Oh, actually meter. So 17.5 meter. Meter. Sorry. Right, so that's the first one. Again, I'll summarize the data. What we know and what we need to find. Right. Angle A is 110 degrees. Little a, we don't know that. Angle B is 20 degrees. B is 3. C, we don't know. And little c, we don't know as well. So that's what we have for our case. So once again, every time we have a pair of opposite sine angle, we use the law of sine. Sine of 110 equal to, over a, we don't know, over sine of 20 degree over b, we know, and then angle c, once again subtract from 180. So that's 50 degrees. And sine of 50 degrees over c. In this case we don't know yet, but we can find that easily. I just pick this 2. And so for c, we have 3 sine of 50 degrees over sine of 20 degrees. Three sine of 50 degrees divided by sine of 20 degrees. 6.7 something. This fit 6.7 feet. Actually, let's write that in red because we found that. Right. And then next, cross multiplying here, and so for a, we have a equal to 3 sine of 110 over sine of 20 degrees. So sine 3 sine of 110 divided by sine of 20. So we have 8.24, so let's 8.2. So the unit of them are feet. So we have angle C is 50 degrees, little a is 8.2, and little c is 6.7. Before we continue, again, the unit should be feet. Sorry, all the measurement, the length is feet in this case, and the angles in degrees. Right. So we continue. Timestamp. Right. Next we have the sine angle. So this is very complicated. I mean, it's not complicated. I should say. This is the ambiguous case. So we have one solution, no solution, or two solutions. So we have to be very careful when. It's not that difficult. We just from the summary and just go one step after the other, and it will detail what we get as we see. Right, so first let's write out what we have. Angle A we don't know B either. Actually we do know B is 80 degrees, and C we don't know. Right, one angle. 2 sine, little 8 don't know, little b 3, and little c is 4. Right. So we have one angle, 2 sines, and the angle opposite to sine. So every time we see this, that is the law of sine. So sine of A we don't know, over A. Sine of B over B, and sine of C we don't know, over 4. Obviously we can only use this, cannot use that. Alright, cross multiply, we have sine of C equal to 4 sine 80 degrees divided by 3. For sine of 80 degrees divided by 3. Right, 1.3 something. It's not a typo, but that's what we have. So C will be sine inverse. Of 1.313, or the supplement of it, 180 minus sine inverse 1.313. Right. But if we put in the calculator sine inverse of that number, it is a typo because sine must be in between -1 and 1. So in this case, that one is undefined, that one is undefined. So we have no solution. So that's what we have on that one. Right. Next we should write very small because I'm not sure what we get. Potentially it could be very long. So A is equal to 30 degrees, little a is 6, little b is 12. We don't know anything else. Right. Again, every time we have a pair of opposite sine angle, that is the law of sine. So sine of 30 degrees over 6 equals sine of B, don't know, over 12, and sine of big C over little c. We cannot use the last ratio because we don't know either the angle or the sine, but the first two ratio, that's good. Let's cross multiply and solve for B. So we have sine of B equal to 12 sine 30 degrees over 6. Right, calculator. 12 times sine of 30 degrees divided by 6. That's convenient. Right. So it's 1. And then we should have two answers. One is B equal to sine inverse of 1. Or the supplement to that, 180 minus sine inverse of 1. Right, sine inverse of 1, that is equal to 90 degrees. And 180 minus that is 90 degrees. So those two scenarios actually are the same, because 90 degrees. So pretty much we can just work on one of them. Alright, so those two are the same. So we have one solution. So just going to work with this. 90 degrees is angle B. And then A plus B plus C is 180. So subtract 180. I should say 90 and 30 subtract from 180, and we have 60 degrees. Right. And then finally, let's write out the law of sine again. Sine of 30 degrees over 6, sine of 90 degrees over 12, and sine of 60 degrees over C. Right. The last ratio, let's just cross multiply, and we have C equal to 12 sine of 60 degrees divided by sine of 90 degrees, which is 1. It's the right triangle, so we really don't need to use the law of sine. We just use the regular trigonometry function. 12 times sine of 60 degrees. Sine of 90 degrees is 1, so we don't really need to have that. So 10.39. One decimal place is 10.4. Right. So in this case, we only have one solution, because those two give us the same thing. Right, so we have no solution, one solution. The next one more likely is two solution. I just want to have at least one example for each. On the test you may or may not do that, but on the review I want at least one for each. Let's write the timestamp first. Right. Again, if there are two solutions, so we have to write very small because that takes a lot of space. Right, angle A, don't know. Little a, 22.42. Angle B, 22 degrees. Little b, 16.8. And angle C we don't know, little c we don't know. Once again, when we have a pair of opposite sine angle, that means we use the law of sine. So sine of A, where we don't know, 22 over 42 equal to sine of B over 16.8 and sine of big C over little c. We cannot use the last ratio, but the first two. When we cross multiply, we can find A. So sine A equal to 16.8 times sine of A divided by sine of 22 degrees. Sorry. So for sine A, so 22.42 times sine of 22 divided by 16.8. 22.42 times sine of 22 divided by 16.8. I'll have 0.4999. It's better just use all of the decimal places. By all I mean, I say 4. Right. So with that, we will find there were two scenarios. The first one is A equal to inverse of that. The other one is the supplement of that, 180 minus the sine inverse. So we skip that values and we just take sine inverse. Second answer. And so that is 29.99. So let's just round that to 30 degrees. And this is 180 minus that, so it is 180 minus 30 is 150 degrees. Right. So let's just put both triangle. So we assume that both of them exist. A 30. Now we know it's 30 degrees. B 22 degrees. Little b is 16.8. Little a 22.42. Big C just 180 minus this 2. So 180 minus 52. I should do this by hand. But anyway, 128 degrees. Right. And that's very easy. We can find the remaining sine using the law of sine. So let's just write the ratio for this 2. Sine of 22 degrees over 16.8 equal to sine of 128 degrees over C. And so for C, C equal to 16.8 sine of 128 over sine of 22. 16.8 times sine of 128 divided by sine of 22. We have 35.3 degrees. So this solution is possible because when we have this information, B is smaller than A and the size opposite to that is smaller than A, which is good. Also, these two don't add up to a number that is less than 180, meaning there is room for the third angle. Right. So that is one solution. And then let's just summarize again. It's worth drawing that summary table here. A, this case 150. Little a we do know is 22.42. B 22 degrees, that also given, and little b is 16.8. Right, we see that bigger angle, longer sine, which is good. And when we add this up, that is 172 degrees, so there's still room for the third angle. In fact, if we subtract this two from 180, 181 minus 172, we should have 8 degrees. And then we'll just use the last two. Cross multiply, let's set up the law of sine. Sine of 22 degrees over 16.8 equals sine of 8 degrees over little c. So cross multiply, c equal to 16.8 times sine of 8 degrees over sine of 22 degrees. So 16.8 times sine of 8 degrees divided by sine of 22. I have 6.24. I just say 6.2. So this is another solution. So it's worth writing this triangle, and what we check for is a bigger angle face the longest side and the smallest angle face the shortest side, and then all the angle add up to 180, of course. Right, so all of those are using the law of sine. Next we have the example where we use the law of cosine. As always, I will draw the summary of the problem, what we are given and what we need to find. Angle A is 45 degrees. We don't know B, we don't know C. Little a, opposite to that, we don't know. Little b, opposite to B, so that is 5. Little c, opposite from it is 4. Right. So we do not have a pair of opposite angle and sides, so that must be the law of cosine. And whatever the law of cosine is, have to have end up with the angle of A. So we have the law of cosine on 3 of them, but we should start with A square because we're going to end with cosine of A. Right. B square is 5 square plus C square minus 2 times 5 times 4 cosine 45 degrees. I'll just do all of that, take the square root, and we have A. Right. So 5 square plus 4 square minus 2 times 5 times 4 times cosine 45. I have 12.71. If we take the square root, we should have the answer. Square root of second answer. And that is 3.56, let's say 3.6. So we have a choice. Now we have a pair of opposite sine angle. So obviously we can use the law of sine here. Right? So it could get tricky, but let us try that. So we use law of sine. Actually, it would be better to use the law of cosine to find angle here, but let us try and see what happens. I said most of this problem kind of reaction type of problem. Just go with what we have at that point and then we move forward. So sine of 45 degrees over 3.6. One thing for sure, whatever we have, the answer for B have to be bigger than 45 degrees for sure. A sine of B over 5. Right, cross multiply, so for B, sine B equal to 5 sine of 45 over 3.6. 5 times sine of 45 degrees divided by 3.6 at 0.988, so that close to 1, so that close to. Right, so take sine inverse of that. Right, 79 degrees. Now there's a problem, because when we fall for B, could be sine inverse. Or the supplement, always like that. And so potentially we have 79 degrees, 0.1 degrees, or we have 180 minus that. That is the big problem now. 100.8 degrees. Right, so that terribly. So I mean, both of them could be the answer. So we cannot tell here, because both of them bigger than 45 degrees. So it's good. Right. So using those two are not the best option. Actually, if we want to use the law of sine, we should use the first and the last ratio. We should use those two ratios. Simply because we know C is going to be bigger than 45 degrees. But we know that C is not the biggest angle. So they rule out the supplements. Right? Once again, angle C is not the biggest angle. So it cannot be more than 90 degrees. In that case, we do not have the supplement case. We only have this first case. So it will be a lot better if we use the law of sine, finding the smaller angle. However, we can also use the law of cosine. If we use law of cosine, then this one will be very clear. Just hope we have enough space. Right, now I'm using the law of cosine. The law of cosine to find the angle B. So this is let's zero in to that. So we start with B square equal to A square plus C square minus 2AC cosine of angle B. So if we start with B, we end up with B. Everything in the middle are the other two letters. Right. If we want to solve for cosine of B, it's going to be B square minus A square minus C square over negative 2AC. Right. Let's try this. We can also use this on the calculator. I'll store all the values I have. 3.6. Let's store that into A. 5 store into B. And 4 store into C, and then just enter that formula. Alpha y equal to, give us fraction b squared minus a squared minus c squared over minus 2 a c. We have 0.1375, and then cosine inverse of that. Copy and paste. Right, 82 degrees. And then we say that is either one of this. Of course, we did not use the whole value, so that we round up a lot. Yeah, so in the 3.6 here, we actually round up a lot. It is 3.56, so we round up a lot. So anyway, so look like it's going to be this one and not this one. Regardless, we use here and we found 30 b is cosine inverse of whatever we just have. I run out of space, so I just have to do that. What that number? 0.1375, and we have 82 degrees. And like I said, the rounding error is very bad in this case, so that should be this one. And I said like 2-3 degrees off. But anyway, so if it's 82 degrees and the rest is easy, subtract off this of 82.1 degrees. 82.1 degree, and then subtract that from 180, and then we should have it 180 minus 82.1 minus 45, and we have 15.4, 52.9. Look at the wrong answer. Anyway, so that's what we have. Alright, again, sometimes using the law of sine to find an angle is not a good option because we have the supplement case. Right, so that's not a very good option. But using the cosine inverse, using the law of cosine to find the angle, there's only one case. So law of cosine, if we have a choice, law of cosine is a very good way to find the angles, because there's only one as possible answer. Right, next. I summarize the data again. Timestamp. Right. Angle A don't know. Angle B we don't know. Angle C we don't know. Little a opposite from the A is 7. Little b opposite from angle B, and little c opposite to angle C. So we have all the sides, side, that is. We just need to find the angle. So I'll just use the law of cosine to find the angles. Again, if we just use the law of cosine to find angle throughout the problem, we don't have to worry about anything. Don't have to worry about this. But if you really want to use the law of sine, I recommend that we start with the biggest angle first, because if it is the biggest angle, then later on we don't have to worry about the supplement, because the first one essentially the only thing that can be is the one potentially is the biggest angle, so that could be supplement. I mean, there is something more than 90 degrees. If the angle is the biggest, potentially it could be more than 90 degrees. If it's not the biggest angle, it cannot be more than 90 degrees. So I start with A first. Start with A. And end with A. Right. Now, I'm going to use the law of cosine a few times here, so it'll be useful if we actually store all the values here. Right. Just like the last one. I store 7 into A. Alpha, A. 6 store into B. And 2 store into C. Right, because we might need to use this again. Right, all we do is just B squared plus C squared minus 2BC cosine of A. Now we don't know A, but that's why we cannot use this. But we can solve for cosine of A. So cosine of A, I'm going to move those two B squared, C squared on the other side. And then divide by negative 2BC. That is the advantage of starting ABC. We don't have to change much. A squared minus B squared minus C squared. Oops. Right. A squared minus B squared minus C squared over negative 2 B C. Right, we have negative 3 over 8. And we just set the cosine inverse. Copy and paste. And 112 degrees. Since we store A, B, and C here, it will be very convenient to solve for the other angle, also using the law of cosine. Right, so if we want to find cosine of B, it is going to be B squared minus A squared minus C squared over negative 2AC. Now, since we store the values into ABCs, that's very easy. B squared minus A squared minus C squared over negative 2AC. 17 over 28. And then cosine inverse of that. B equal to cosine inverse of 17 over 28. So cosine inverse of that, 52.6 degrees. We can also do the same thing and find the angle C, but we just subtract from 180. So 180, subtract that one, and subtract that one. We have 15.35, so 15.4 degrees. Yeah, just subtract these two from 180, and we should have it. Right. Next, we'll convert between rectangular and polar coordinates. So, this will be the relation. We have x equal to r cosine theta, y equal to r sine theta, and then we have r squared is equal to x squared plus y squared, and then the tangent of the theta is equal to y over x. So those are what relate. Pretty much we have a point in rectangular coordinate. We have x and y, meaning y and x here, and we can also write that in terms of the two components of r and theta. So in polar we have r and theta, in rectangular we have x and y. Right. So we have x. First, x equal r cosine theta. -7 is r. Cosine of 2 pi over 3. Right, cosine of 2 pi over 3 is negative cosine pi over 3. Pi over 3 -1/2, so -7/2. I should say -7 times -1/2 is 7/2. Right, so that is x, and then y will be the same way. Kind of run out of space. Let's just try to put that here. R sine theta, -7 times sine of 2 pi over 3. Right, so -7 times square root of 3 over 2. So -7 square root of 3 over 2. So pretty much we have x and then y. So the rectangular coordinate is going to be x equal to 7/2 and y -7 square root of 3 over 2. Right. Next we have rectangular coordinates. We're going to change back to polar, meaning the answer is going to be r and theta. So it's straightforward. We just do this. R squared equal to x squared plus y squared. So r equals square root of x squared plus y squared. Square root of square of 3 squared plus 1 squared. Square of 3 squared is 3 plus 1, 4. Square of 4 is 2. So r is 2. Tangent of theta is y over x. 1 over square root of 3, and inverse of that is 30 degrees. But since the calculator is still in the degree mode, we just say tangent inverse of 1 divided by square root of 3. Oops. There. 30 degrees. Which is pi over 6. So the answer in polar coordinate, we have r is 2 and theta pi over 6. So r and theta, rectangular x and y. Sorry, r and theta, polar coordinates, x and y, rectangular coordinates. Next, we need to write this in terms of the polar coordinate, polar equation. Right. So first, every time we say x squared and y squared, so that's why I'm free, because that one is r squared. That's the easiest one. We have minus 4x equal to 0. And then also x is r cosine theta. Let's do 4, of course, and then move the 4r cosine to the other side. R squared equal to 4r cosine theta. If we divide by r on both sides, we have r equal to 4 cosine theta. So that's one obvious. Next, also relatively easy. X is r cosine theta. Y is r sine theta. And we have 2 and 3 equal to 6. And I don't think we can go any further than that. Yeah, but there's nothing simplifying, so we can just leave it like that. Right. Next we go to the vectors. Right. First, if u is that, v is that, find the sum of the vectors. So that's one simple. Just the notation for vectors. We have vector u plus vector v. We have 9i minus 3j plus negative 2i plus 9j. So if we write like that, it just combine like terms. Yeah, that's still a plus 9j. So 9i minus 2i, 7i. And minus 3 plus 9 plus 6j, sorry. Right. For the timestamp. Next, we do this. So 5 times vector v. So we do that first. 5 times vector v. 5 times this. So it'll be 10i plus 25j. So we find the magnitude of 5 times vector v, just the square root, this square root of the sum of the square of the components. So we do that. 100 plus 25 square. So 725. So we don't have to simplify this. But notice 725 divided by 25 is 29. So we can have 25 and then 29, which is just 5 square root 29. We don't have to do this, just stop at square root 725. That's perfectly fine. Right. Next, find the unit vector in the same direction as v. Meaning that we're going to find the vector u, which is found by v divided by the magnitude of v. Right. So we need the magnitude of v. V is 12i plus 5j by the way, I can also write as this notation, which is fine. Either case, the magnitude is just the square root of the sum of the square of the components. 12 square and 5 square, that's 13 square. 169, so that's 113. And finally, we just put in that form unit vector in the v direction equal to 12i plus 5j divided by 13. And if we split, we have 12 over 13 I plus 5 over 13 j. That's all we do on that one. Next, determine whether the vectors are parallel, orthogonal, or neither. Parallel, if the vectors are parallel, they must be the multiple of each other, meaning that v is equal to k times w if they are parallel. So, like the first one, if we multiply by 2, the second one we don't multiply by 2. So this is not parallel. So that's one clear. 2 divided by 1, and we just take the ratio here. 2 divided by 1 is not the same as 1 divided by negative 2. So they're not parallel because we don't have that. Right. Orthogonal. Orthogonal is kind of like perpendicular in geometry, but this one for vector, so we define that to be in the new term is u dot v equal to 0. So do the dot product pretty much. So vector v w. Okay. Pretty much just do the dot product of these two vectors, v dot w. Now let like I said, we can switch between ijk components, or we just have the 2 and 1 in angular bracket like that. 1 and negative 2. So the first with the first, 2 times 1 plus 1 times negative 2, and that is equal to 0. So yes, so they are orthogonal. Next, we have a work problem. A wagon is pulled horizontally by exerting a force 60 pounds on the handle, angle 25 degree of horizontal. How much work is done moving 50 feet? So the wagon is pulled at the force of 60 pounds, and that move 50 feet. Angle between them 25 degrees. So the work is the force dot the distance in the vector form, or we just say the magnitude of the force times the magnitude of the distance times the cosine of the angle in between. So we have 60 pounds, and D is 50 feet, and the angle 25 degrees. $60 times 50 times cosine 25. So yeah, we're still in degree mode. So we have 2,718.9 foot-pound. Next, the distance of P1 and P2. So first, the distance of P1 and P2 is pretty much is going to be the magnitude of the vector connecting them, pretty much. And then so pretty much we find the vector first. So we are given 2 points. So the vector P1, P2 is found by take the P2 minus P1. The final minus the initial. The end point minus the hat. Right, P2, negative 3, 0, and 1. Subtract negative 1, 2, and negative 2. Right, negative 3, negative 1. So notice when we subtract, those are the points. We will switch to the notation. Negative 3 minus that the plus 1, so minus 2. 0 minus 2 is negative 2. 1 minus, so that is the 3. Right. If we use the calculator, well, we can use the list like this. Second parentheses, that gives us a bracket of negative 3, 0, and 1. Close. Subtract another set of negative 1, 2, and negative 2. Have negative 2, and 3. So pretty much we have the magnitude of a vector of negative 2, and 3. So Pythagorean theorem. So 449 square root of 817. Right. Next, we find 2v plus 3w. They're the dot products. Right. Again, 2v plus 3w. Actually, right when the IJK is, there's nothing wrong for that, nothing wrong with that. But it is easier, more compact if we just use the angular bracket. 2, negative 5, and negative 3, and then plus 3, 4, negative 6, and negative 5. Right, so 2 times 2, negative 5, negative 3. The linear combination of vectors, we can do this. 3 times 4, negative 6, negative 5, negative 5. Close. Right, 16, negative 28, and negative 21. So we can write a vector like that, or we can write in IJK notation. Right. Next, we find the dot product. V dot W. Right. So when we see the dot product, it's better to write this into angular bracket notation. So 3, 1, 2, 1, 2, negative 3. First with the first, second with the second, and third with the third. 3 plus 2 minus 6 is minus 1. So dot product is minus 1. Next, find the angle between the vectors. The angle between the vectors first we have dot product equal to the product of the magnitude times the cosine of the angle in between them. So if we want the angle, we just take the dot product divided by the magnitude the product of the magnitudes. Dot product of the first one V, if we write ijk component 1i, 1j, no k, dot 1i, 1j, negative k. And then the magnitude of V is 1 square plus 1 square. And the magnitude of W, 1 square plus 1 square plus negative 1 square. Right. When we clear everything, we have square root of 2 times square root of 3 at the bottom, or square root of 6. On the top, 1 times 1 is 1, 1 times 1 is 1, and 1 times negative 1 is 0. So we have 2 over square root of 6. And cosine inverse of that. Right, still in degree mode. Cosine inverse 2 divided by square root of 6. 35.1 decimal places, so 35.3 degrees. Right. Next we have the cross product. Find V cross W. Right. So V cross W. The cross product is 3 by 3 determinant. The first row is I, J, and K. And then we have the first vector 6, negative 2, and 1. And W is 2, 5, and negative 1. Right. So 3 by 3 determinant. It will help if we have something like this. So first, I'm going to cover the first row and the column that containing the numbers. Right. So first, if we take out the I, cover the row and the column that containing the I. So what's left is negative 2, 1, 5, and negative 1. Right. Next, it's going to be subtract. So the sign always alternating, plus, minus, plus. Now we cover the row and the column that containing the J. And we left with 6, 1, 2, negative 1. And then for K, again, plus, minus, plus. 6, negative 2, 2, and 5 for K. Right. And then it's just 2 by 2 determinant, meaning cross multiply and subtract. Negative 2 times negative 1 is 2, minus the other direction. That is in I component. Next, 6 times negative 1 is negative 1, minus 6, sorry, and minus 2 in the j component, and then for the k, 6 times 5, 30, minus negative 4 plus 4 k. So we have negative 3 I plus aj plus 34k. Or we can write negative 3, 8, 34 like that. Either way works. Right. Next, pretty much haven't. Let me write the timestamp first. Next, we just find a vector that is orthogonal to both v and w. So in the application where we have the cross product, let's say we have two vectors like this. When we find a cross product, we're going to have a vector in the third direction that is orthogonal to both of these, orthogonal to the plane containing the two vectors. Right. Of course, it could go up or it could go down, but it's going to be orthogonal to the plane containing the vectors. To determine if it point up or down, we just use the right hand rule. But here, all we do is just find the cross product of v dot v cross w. So I, j, and k. Negative 5, negative 3, 1, 2, negative 5, and negative 1. Right, do that again. Row and column covering. The first one, hope you can see it. Right, that's better. Negative 3, 1, negative 5, and negative 1, I. Negative 5, 1, 2, negative 1, j, and then for k, negative 5, negative 3, 2, and negative 5, k. Right. Negative 3 times negative 1, that's 3, subtract that plus 5. That's in I component. For j, negative, again, that will be 5 minus 2 in j. And for k, 25 plus 6 k. So I have 8 I minus 3 j and 31 k. Or we can write in this angular bracket notation. Right, next, the area of the parallelogram. So let's say we have a parallelogram. So say we have P1, P2, P3, P4. We assume that the points are given in that orientation. They're not going to trick us with P1, P2, P3, P4 kind of twisted around. Right. Let's assume that is nothing just in that order nicely. So what we do is we're going to find a vector connecting P1, P2. And then we find another vector connecting P1, P4, and after that we take the magnitude of those two vectors. Let's say this is V and that is W, so we just do the cross product of V and W and then find the magnitude, because the cross product is a vector, so we have to find the magnitude to have the area. So pretty much first we find P1, P2, then P1, P4, then do the cross product. take the magnitude. So those steps. So first P1, P2. P1, P2 is the cross product. P2 minus P1. P2 4, 1, 10 minus P1 7, negative 5 and 5. I use calculator here. List 4, 1 and 10 minus 4, 1 and 10, that P2 minus 7, negative 5 and 5. Close the list. Negative 3, 6 and 5. Right, next P1 and P4. Going to be P4 minus P1. P4 is 0, 3 and 13 minus P1 7, negative 5 and 5. Right. 0, 3 and 13 subtract 7, negative 5 and 5. Negative 7, 8 and 8. Right. Next we're going to find the cross product. It doesn't matter which order we do the cross product. I just do P1, P2 cross P1, P4. I, J, K. P1, P2, negative 3, 6 and 5. Negative 7, 8 and 8 for P2. Right, let's do that again. 6, 5, 8, 8. Direction, and then minus negative 3, 5, negative 7 and 8 in J direction, and then plus negative 3, 6, negative 7 and 8 K. Right. 6, 8, 48 minus 40 in the I direction, minus negative 24 plus 35 in the J direction, and then plus for K negative 24 plus 42 K. Right, so that gives us 8I. 35 minus 24, that's 11, minus 11J. And 42 minus 24, that's 18K. And then we just find the magnitude of the cross product. We can write that as 8, negative 11 and 18, and square root of the sum of the squares of the components. A square, negative 11 square, and 18 square. A square, 11 square, and 18 square. I have 509. Right, that's what we have. Again, we assume that the point arranged in some certain orientation By that I mean clockwise or counterclockwise and not crisscrossing. So in that case we have P1, P2 and then P1, P4. Just two adjacent vectors, do the cross product, and then take the magnitude. That will be the area of the parallelogram. So that's all we have on this review.